Okay, so it's ready. So today, as I already told you, we have a special guest. He told me to call him Xavi, but you can pronounce your name for at least once.
I'll
name.
try.
How is it?
So the full name is Szabolcs, but just call me Xavi.
Xavi, magic.
All my Spanish friends just call me Xavi.
So he's a CTO from ioteelaab, that is a company in Denmark. And he's going to tell us today what they do in this company that is very closely related to what you're learning in this master, so just perfect.
Yeah. So, hola, bienvenido. Gracias para su invitación. Puedo hablar un poquito de español, pero no muy bien, y entonces lo voy a tomar en inglés. Pero si tienen preguntas, y es más fácil, pueden preguntar en español también. Vale. So, yeah, this is the agenda. I'm just going to say a little bit about who I am. Then I'm going to present ioteelaab, our company. Then I'm going to talk a little bit about IoT and business models. Then I will give 2 examples for IoT on projects that we worked with. And then I'm going to talk a little bit about machine learning and give an example there as well. And if you have any questions, just interrupt me. Ask as much as you want. Okay, so who am I? So I started ioteelaab together with my partner last year. I have some experience with software, and I worked for 4 years in the wind turbine industry. As you will see from the IoT projects I'm going to present, some of them are going to be related to wind turbines. Then my bachelor's is in electronic design engineering, which basically just means that you study hardware, software, and electronics. And my master's degree is in technology-based business development, which is a fancy word for how you can make businesses out of technology. But that's my professional background, that's my studies, but who am I as a person? So I'm really passionate about technology. I also like speaking in public. And in my free time, I built a 3D printer. I ordered a kit from China, and I spent like 30, 40 hours building it and then optimizing it. It was really fun. Then I'm also working on a self-driving car, on a robot which walks. I really like going to hackathons and trying out new things. I went to one organized by NASA and by Bosch, and it was really, really fun. And I also like going climbing. That's why I asked. I like mountains, books, etc.
Are you going to talk about self-driving car?
No, not today. Not yet, at least. All right. So ioteelaab. So ioteelaab is the company that we started in 2017. Later on, you will hear the story behind why we started the company and what we're working with. But for now, I'm just going to say that our focus areas are IoT, smart cities, and we're also working with machine learning, connectivity. We're organizing workshops and hackathons as well. And we structured our company as an innovation sandbox. That basically means that the way we work is that we have an idea, and then we build a prototype. We test it out. We test the technical feasibility, but we also test out the business feasibility, because we want to make sure that our product works, but also that our product is something that we can commercialize. And if it seems that it satisfies both, then we make a small company out of that, and we let that be its own entity, and then we move on and we make the next one. This way, we always have fun with innovating new things all the time, but at the same time, we don't get stuck on working just on one thing. And we're also working with customized IoT solutions and with integrating data with clouds. So yeah, here you can read all the fancy corporate stuff, what our vision is, what our mission is, what our goal is. We are very ambitious. We want to be among the top 10 most successful startups within the IoT in the next 10 years. And yeah, basically we believe in a future where technology and business work together through innovation. So before going into IoT, I just want to see how many of you know about the Gartner Hype Cycle? Okay, 1, 2, 1.5. Yes. Okay, so the Gartner Hype Cycle is very interesting because it's made by Gartner. It's a chart where they take all the technologies and then they plot it. And basically, you have on the y-axis, you have the expectations, how much people expect from this. And on the x-axis, you have these 5 dimensions. So if we look at this, then first of all you have some innovation, which triggers a new technology. Then you have the peak of inflated expectations. Right now, machine learning and deep learning is on the top. Everyone is talking about it. Everyone is saying that it's going to be the next big thing, and we're going to see what's going to happen. Then you have the true-off disillusionment, which basically means when you actually go down from the hype and you try to apply it in some real-world scenarios and find out, is this actually something useful? The slope of enlightenment, when you have gone through that part and you actually found an application for it. And then you have the plateau of productivity, when you actually turn a technology or a concept into a product. And if we look at IoT, right now it's actually still going up, so it's still expected to reach the peak, and we're going to hear more and more about it. And then with time, it's going to mature a bit more. So some people actually argue whether IoT is a foundational technology or a disruptive one. So a disruptive technology, for example, is one that changes things very quickly. You have iPhone, like the classical example, but I'm just going to mention Uber or Airbnb, or the whole culture we have nowadays where we try to use people and we try to servicize things. So that's kind of disruptive. But is IoT disruptive or not? That's also an interesting thing to think about. Going a bit more academic, what IoT is. So some say it's a buzzword, but one definition is that it's a collection of building blocks that's not complete. And here we have an example of what the architecture could look like. So basically you have three main layers. You have the sensing domain, where you have the device itself, which measures something. That's running on some hardware and it has some software running on it. It can be, for example, an air quality sensor. Then you have the network domain, which is the connectivity, which actually ensures that you manage to get the data from the sensor up in some kind of cloud. And then you have the last layer, the application domain. That's basically where you actually use the data for something. And this is very interesting for us because everyone right now is putting up sensors, everyone is measuring something, but not many people actually know what to do with the data. So this is very interesting for us actually to find out how we can extract the value from the data. And this is something that's very difficult to do if you only have the engineer classes on. And I know because I've been an engineer for more than a few years, and now I'm starting to understand the business aspect. And I just want to share with you in the following how you can also put on the business classes in a way and try to understand how the technology can actually be used for something. So in order to do that, I'm just going to briefly talk about business models. How many of you have heard about the business model or know what it is? Okay, so not that many. So basically, the first question is, and it was in my head, is like, why should I care? You know, why should it influence my work? And you know, as engineers, you know, we like to do things because they're fun. We like to play around. We like to hack. We like to make something because it's cool. People ask, what is this useful for? And normally we just say, well, because it's cool. We do it because we can, right? And then on the business aspect, the mindset is very different. It's more about trying to earn money on something, generate some revenue, and the technology is just a means to do it. So what I have experienced and what I'm seeing right now in our company is that when you manage to combine the engineering and the business mindset, that's when you actually hit the sweet spot. So how do business models work? Westerwoude, he's one of the famous academic guys who talks about business models, and basically he just says that business model is a way that the company does business by making some value to the customer. So business models have been around for a long time, but they are still not very well understood. And I'm just going to briefly present a way of looking at business models, which is very simple and which has been developed especially for IoT. And this was developed at the St. Gallen Research Institute in Switzerland, which was actually funded by Bosch. So it's also interesting to see how the big companies sometimes, you know, they realize that they can't do all the innovation in-house, and then they decide to partner up with universities, set up institutes where they can do some research. So the St. Gallen Business Model Navigator basically has four main questions. The first question is, what are you offering to the customer? Let's say you are growing oranges, so you offer an orange. Okay, that's your value proposition. How is the revenue created? I sell the orange, I get money for the orange, and the money I get for the orange is more than it costs me to grow the orange and to pay my employees. Who is my customer? Who is your target customer? Who actually buys the oranges? Is it a business? Is it someone in a supermarket? You need to understand that well in order to properly have your business model working. And then how is the value proposition created? How is the orange delivered? Because it grows on the trees. Someone needs to pick it. Someone needs to put it into a box. Someone needs to put the box on a truck. The truck needs to carry it to a store. You need to buy it from the store. So that whole journey, that's called the value chain, and it can be used for technology as well. So an interesting thing is that more than 50% of innovation fails because they don't always consider the business aspect and because they don't know the customer. And when you think about how the value is created, you have to think, why should the customer pay for this? What are you actually providing for them? What kind of service? And when you think about digital IoT value chain, is the value chain example I gave you for the orange was how you deliver the orange to the customer, but in IoT, it's basically how you get the data from whatever you're measuring up onto the customer. So let's say, for example, that you're measuring air quality in a city. In order for you to deliver that, you need to have a sensor. That sensor needs to measure the air quality. Then the data from that sensor gets sent up to a cloud. It can be through GSM or LoRaWAN or whatever. And once it's in the cloud, if you're the one doing the data processing, then it's done. If your customer is doing it, then you need to have some kind of external API so that you can link the data to the customer. So now I'm going to walk through 2 examples of IoT, and let me know if I'm talking too fast or something, because I can get talking fast sometimes. So the first example is going to be about asset tracking in the wind turbine industry. And the second example is going to be about waste management. So when you're looking at the wind industry, then the way it works right now is that you have some companies which make the wind turbines, such as Vestas and Siemens Gamesa now. And those wind turbines, they have panels, the electric panels, which contains all the components which are controlling the wind turbine. And then you have other companies which are manufacturing these panels for the big companies. And I was working for one of these companies, and then I had to look into how they can use IoT. And then throughout my master degree, I got to write a scientific paper on this. So I'm just going to present the content of this paper, which will detail the IoT section. So this paper was called a case study of IoT as a driver business model innovation in the wind turbine industry. Basically, it just means that we looked into how you can take an IoT sensor and how you can use that in order to track how the panels are being transported. So in this case, just imagine that you have a company which has a factory in France, and then the panels need to be taken all over the world. And the issue that comes up sometimes is that the panels can be damaged, and then they get installed in the wind turbine, and then they fail. And then how can you prove that the panels were manufactured correctly and that they didn't fail during the journey, for example? Also, you can use it to optimize logistics. If you can see that one shipping route always takes too much time, then you can change that. And you can also actually use it to check if your shipping company is being honest with you. Because sometimes they say, oh, yes, we have it on the container, it's leaving tomorrow. But then when you look at the data, you see it only after a few days. So our assumption was that there is some kind of value in tracking these panels. And in order for us to figure that out, we decided to have an MVP, a minimum viable product. Has any of you heard of that? So basically, the minimum viable product, it means what's the minimum amount of features that you need to make in order to prove that something works. So this, just to give you an example, let's say that you want to make a bike. You're just going to take 2 wheels, a chain, and some pedals and connect it. You don't need to put a lot of gears and etc. You just want to test out if the bike works. So in this case, for example, we didn't want to spend 1 or 2 years doing R&D, building a sensor that's very advanced. Instead, we just wanted to take something that already exists and then try to test it out as quickly as possible. Because it could be that there is actually no value in this, and then why spend 1 or 2 years developing it? So what we did here was we had some customer requirements. They said that, okay, the battery has to last for 2 or 3 months. It needs to measure every 10 minutes. There were some requirements for what kind of measurements it should have and how it should integrate with the customer cloud. Then I just looked at different devices and tried to figure out which one fits best. And then I found the device which was actually quite okay for this. It was plug and play. It had a built-in GPS. It had some additional measurements such as temperature, humidity, shock. So we could actually measure if the shipment was exposed to some kind of shock. And it had, of course, GSM connectivity. So we just put in a SIM card and it works. So we decided to test out this device, and I'm just going to have a journey for you now where you can actually imagine how this device works. So first thing first, you have the device. You mount it on top of the panel or wherever you feel like. Then the panel is loaded onto a truck. As soon as this happens, the data starts flowing in. So the sensor starts sending in the measurements. And this data can be seen by the company who owns the sensor. So let's say that something happens, there is an accident on the highway, and then you can see that the shipment has stopped. On the company side, the one that manufactures the panels, they will receive a notification that the order is delayed. And so will the customer. So they will actually know if the shipment is delayed in a similar way to if you buy something from Amazon or whatever and you can track the shipment, but you do this for businesses. Because panels like this, they can cost, I don't know, tens of thousands of euros. So when you're investing so much money, then you really want to know in what condition your product is being transported and when it's going to arrive. So this shipment is very unlucky. It gets hit by a car, and then the sensor on the panel measures that it has been exposed to shock. This shock is more than the specifications it has been designed to. And then, okay, I'm missing something here, but just imagine that then the company gets notified that the shipment has been damaged, and they can send out a new shipment to the customer. Then the customer gets the shipment and everyone is happy. So how was this implemented? Technically, we just had the sensor. We had the infrastructure in Microsoft Azure. And we were storing the data, and then we had some kind of web application where we could see. So basically, you could see a map here with all the spots where the device went. You could see a heat map, which can be useful to see if a device spends a bit too much time in one given location. And then you could see the different measurements. And one more thing is that another thing we use this for is actually to track parts. Because you know when you had this crisis with, I think it was chicken meat or milk sometimes, and then you want to be able to trace back the milk or the chicken to all the shops so that you can take it out of consumption. The same can happen with components. If, for example, you have a faulty component that has been manufactured in 1,000 units, and that one gets installed in 1,000 turbines, you want to be able to track it back, because then you can remove it and you can make sure that it doesn't fail. And by having this information that is linked from the panel to a location where the panel is delivered, you can trace it back. So how was this tested? We took 5 panels. We put in different sensors on it with different configurations. We wanted to see if, for example, it measures once every hour, once a day, which one is going to work. And there was a lot of things we didn't know here. We didn't know if it's actually going to send the data. We didn't know if it's going to work for a container. So that's why we decided to have this MVP mindset where we just try it out. And if it doesn't work, then we just do a new iteration and try that instead. So here we had a shipment going from Poland, I think, to the Americas. And we could actually see on the map how the shipment was moving. And then it proved out to be a success.
If they're put inside the containers, metallic containers, like Faraday cages?
Yes, it surprisingly still worked, yes. You could actually see how the shipment was moving, and then it went to Germany, and then it got on the ship. And then we still got 1 or 2 measurements when it was going nearby a port. And then the next measurement we got was when it arrived to America. But surprisingly, it still worked, yes. The GPS location didn't work, actually. So it was a GPS location.
Yeah.
Yes, that didn't work, actually. So we kind of had to do a hack where we did the mobile connectivity we were using. They offered an API for triangulation. So we could actually get an approximate location from the network provider, which was okay for this case because doesn't matter if it's 300 meters off, you can see where it is. So yeah, the GPS didn't work. And we found that out by testing it out, actually. And we also found out that, depending on if the GPS is turned on, it was killing the battery. And then we had to disable it remotely. But luckily, this device had that feature, so we could actually update the configuration remotely. So previously, I talked about business models, and then now let's try to see how we can put this inside a business model. So who is the customer in this case? Well, you can have 2 customers, basically. You can have one, which is the company that makes the panels. And then the other customer can actually be the one that actually buys the panels so that they can track where the shipment is. What kind of value are we creating? Well, as mentioned earlier, we can detect if the panels have been damaged. We can optimize logistics. We can share the location with the customer. And we can handle warranty claims if, for example, something breaks and then we need to know who is responsible for it. And what is the digital IoT value chain? You have a sensor which sends some data through GSM. It's stored in a cloud, and then the data is visualized. What is the revenue and cost? So when you calculate this, basically you just need to add all the costs that you have. So in this case, you had the cost of the device, then you had the cost of implementing the software, of maintaining it, and then we have to figure out what's the revenue stream, how are we going to earn money in this. So this business model navigator, it has, I think, 56 different examples on how you can earn money. And one of them is a subscription-based fee where you pay something every month to use the service. That could be one way of doing it, where, for example, you have a company which will pay you, 5 euros per shipment each month. Another way of doing it could be that you will give this as an extra. So if your customer wants to see where the shipment is, they need to pay something extra. That's also something that's provided nowadays by DHL or the postal service. If you want to ship your product and you want to track it, then you have to pay a bit more. That could be another way. Basically, it's just how you're going to earn money on it. All right. How is it so far? Was it clear? Make sense? Okay. So now I'm going to talk about waste management, and I'm going to tell you guys a little story. So how we actually started working with waste management. So just imagine that you have a party, you drink some nice wine and everything, and then the next day you need to go down to the recycling bin and put in all the glasses. Okay, let's say that you have a lot of friends, you have a lot of glasses of wine, and then you go down with like 2 very heavy bags, and then you arrive to the container, and guess what happens? It's full. So basically, you just have to walk all the way back to the apartment with all the glasses, and then you start thinking, there must be a smarter way to do this. And the city where I'm living, it's also a smart city like Santander. And that kind of got us thinking. And then we figured out that we want to understand, we want to measure when the bins are full so that they will be emptied beforehand. And that's when we started looking into waste management. So basically with waste management, we want to understand how it works by measuring when the containers are full, when they need to be emptied. And then this information can be used to improve the efficiency so that the bin will never be full. And then, for example, Santander will be cleaner and more CO2 friendly. And also you can improve the efficiency by up to 40 or 50% if you measure it. And then we started a company, and we applied for some funding through Organicity. Organicity is kind of like a middleman between the European Union funds and startup companies. So basically, if you have a good idea, you can apply for some funding and they can fund your experimentation. And right now, we are running an experiment in 3 different cities where we are installing our sensors. And we're trying out 2 other things as well. And we have 2 cities in Denmark and, of course, Santander. So how did we decide to measure it? So you have basically, we thought of 2 ways of doing it. The first one is when you have a sensor which measures the distance. So it just has an ultrasonic sensor inside. It measures the distance. We mount this inside a container, and then we can see how full it is. We get the data. We use some kind of hardware, and then we use LoRaWAN. I don't know if do you guys know about LoRaWAN? Anything? Yeah. So LoRaWAN is it's a narrowband communication infrastructure. You can think about it kind of like GSM in a way. So basically, you have a device which can send information up to 12 kilometers in open sight, but in cities it's more like 2 or 3 kilometers. But the very interesting thing is that LoRaWAN is completely open. So in principle, you could buy a gateway, you could set it up, and then you could have your own data being collected. And that's what we did in Denmark. In one of the cities, they didn't have LoRaWAN connectivity. So we got 2 gateways, we set it up, and now anyone in the city can set up their own sensors and use the data for free. And what could you do with this, for example? Let's say that you live in a very noisy neighborhood and you really want to complain to the authorities and get some kind of tax reduction. I don't know how things work in Spain, but you just want to complain, okay? And, sorry?
That's it.
Yeah, and then if you just complain like this, they're going to say, okay, but if you have some data, then you actually might get somewhere. So let's say that you just go online and then you just buy a very simple IoT kit, Raspberry Pi, whatever. You put in a microphone and you start measuring how loud the street is. You connect to the LoRaWAN network, and in a few weeks you have some data that you can take with you to the municipalities. I'm just going to send this around so you can have a look.
So your company builds this?
Yes. Yes. At the moment, actually, we're using off-the-shelf components. So we're not building the sensors ourselves. We're not building the hardware ourselves. We're just finding the right pieces and putting them together. And this is already our 3rd or 4th prototype. We're also using the MVP way of thinking so that we don't spend a year developing this. We have something that we think works. We put it in a container and we check it out. And if not, then we iterate. Like, just to give you an example, we had some issues with the sensor we were using. It worked well indoors, but not outdoors. And then we saw that when the temperature went down or the humidity went up, it wasn't measuring accurately anymore. We had to try another sensor. Then we noticed that, okay, some water was getting in. That's not good. So we had to make it more waterproof. Then we noticed again that the measurements were not accurate enough. We had to try another sensor. So we had to iterate a lot until we got somewhere that was okay. But that's the sensor. And then we had another way of figuring this out. And this is using the citizens. Because if you think about it, like in Santander especially, you have these green bins, and you can look into it, and most people can tell if it's full or not, and they can even guess how full it is. You don't need a sensor for that, necessarily. So what we decided to do is 2 things. One of the things is just to set up the stickers, which you can now see in the city. We put it up in the neighborhood of, I don't know how it's called, but I will tell you afterwards. But we put it up on 5 containers. And then the idea is that, let's say you're walking around and then you see this sticker and you're like, oh, gana 2 entradas de cine. And you're like, wow, I want to cinema tickets. Then you scan in the code, or if you don't have a QR code reader, you just write in the page. And when you do that, then you get to this page here. And here you can just drag the slider, and you can kind of guess, how full it is. You put in your email address, your name, and then you send in your supposition. And then at the end of the month, we just compare the estimates we get with the actual sensor measurements. Because we don't tell the people, but we also have one of those sensors inside. So we can actually see how full it is. And this way we can actually test out if we can have people help us out. And then you might be thinking, okay, the QR code is nice, but not everyone in the city has a smartphone, not everyone knows how to use it, not everyone cares. So the other way of doing it that we thought about was using a button. People like pressing buttons, so it's fun. And the idea is that you just press the button every time you put some glass inside. And then, okay, maybe sometimes you put 2 glasses, 3 or 4. How is that going to look like? We assume that over time you can actually average it out, and then we can try to see some patterns into this. And at the same time, we also hope that people will find it very easy just to press the button. And then, of course, we might run into some issues. You might have kids that just press it all the time. Then we need to put a timeout that you can only press it every hour or so. Another issue is that somebody might steal it, I was told. So we just use some very strong epoxy glue. So right now you could probably take it, but you have to take the container as well. So yeah, that's where we are right now. And then we put up 2 of these buttons in Santander. So we're very curious to see how they work. And in order for us to actually understand how people feel about this, we organized some workshops. And then the first workshop we had was in Denmark, where we had this 6 dimensions. I'm not going to go into the details, but first of all, we just presented what we're doing with the button and with the QR codes. And then we just asked people what they think about this, positive, negative. The second thing is we asked people to tell us stories about what kind of things happen to them when they go to the container. And some are really funny, some are not so funny. And then we also asked them what kind of things would motivate them to press the button or to use the QR codes. Then we also asked them what kind of information would they like to find about this project, and then what kind of ideas and feedback they had. We did this in Denmark, and then yesterday we did this in Santander as well. We had actually 8 people joining us, and it was really, really interesting to see people who are like, I think the average was above 50, sitting down, taking post-it notes, writing stuff, and it was really, really amazing to see how they engaged and how they wanted to share their ideas and what they think. And then the summary of yesterday's workshop is that people think that the button is simple, it's funny, it's innovative, it gives a sense of community, purpose, they're open to the idea. But of course, they also had some negative feedback, which we really liked because then we know how to improve it. So they think it's they would like something to be closer to the restaurants, because let's say that you have some business owners like these guys, and then they have a lot of glass that they need to throw out because people drink wine in the restaurants, and then they would like something that's closer, they can use it. Another one is that, oh yes, the neighborhood is called Tétouan. Tétouan, I guess you guys know it. Yes, it's called Tétouan. Sorry? Yeah. And then the other one was, what about children? Maybe they will just press it all the time. Maybe the sensors will be stolen. And then in the end, we kind of felt like we need to think about who our target group is. It might be that the button will work for a certain age group, the QR code will work for a certain age group, and we might need to have another solution for this. We'll find out once the experiment runs. So that was about waste management. If you guys are still alive, I can talk a little bit about machine learning as well. Okay, so I just found this picture and I thought it's very funny. It was initially for big data, but I think it's for machine learning as well. And to be honest, I was also guilty of it, of the machine learning part. Because before we started this project, we were always talking with some people and we were like, yeah, we're just going to do some machine learning on it. It's so easy, And then we actually got a real project. So we decided to work on this because we wanted to take something that's hyped, turn it into something tangible and something that can bring some kind of value. We believe that it will unlock some business opportunities. And we were also very lucky to have a good relationship with this wind turbine company that gave us a lot of data. And I guess if some of you guys are working with machine learning, then you know that having good data is extremely important. Um, so what's the project about? It's called the detection of faults in wind turbine main bearing using machine learning techniques. So I'm not going to explain you how wind turbine works, but you have the blade here which is rotating, and then it's rotating on a shaft, and that shaft is sitting on a bearing, and that bearing over time it wears out. So what we had to do is we had to somehow estimate what's the temperature of the bearing by using other variables. So we knew what's the temperature in the nacelle, the box on the top. We know what's the temperature outside. We know how much power the turbine is producing, and we know how fast it's rotating. So we had these variables, and then from this, we wanted to see if we can use machine learning, more specifically neural networks, to try to estimate the temperature of this by using other variables as well. So let's see how this went down. Before I go into the solution modes, just an overview of machine learning for those of us who haven't worked much with it. So you have two types. You have supervised and unsupervised learning. In the supervised learning, the idea is that you kind of try to give the algorithm the right answer, and then you try to make it so it learns. So let's say that you want to do some image recognition. You want to make a program that identifies apples. So let's say that if you want to do that, then you just feed the neural network with thousands of images of apples. And eventually it's going to become better and better at identifying apples. That's when you have supervised, and unsupervised, that's more used when you want to see some patterns, you want to cluster some things, and so on. And then the core of every neural network is a neuron, and this is a simple one. It's just a single input neuron where you have some kind of value that goes in, and then you have a weight and a bias that you multiply it with. So basically what you want to get out of this is you have the temperature of the nacelle, you have the temperature in the box, and then you know what's the temperature of the bearing. So you want to figure out how can I get the temperature of the bearing knowing the temperature inside the box. So you need to multiply it with something, you need to add something to it. That's the weights and the biases, and then it gets more complicated, but I won't go too much into that.
So, sorry, your case was supervised?
Yes, I was supervised, yes. So we basically started from scratch. We didn't know anything about machine learning. So first we read a lot of articles, we read some books about it, and then we got started. So we decided to use the MATLAB neural network toolkit because that made our life a bit easier. We didn't need to implement everything, but we actually also tried it out in Python, because in Python you can use Google's deep learning libraries. And the nice thing about Python, like when you're studying, MATLAB is perfect because it's free. But when you have a company, MATLAB is extremely expensive. That's why a lot of companies, they are looking into something that's open source, like Python libraries. So initially we just used the Sigma neural network, and not going to go into all the details, but it didn't work very well. So our error was around 65%. And then we tried changing different things. We tried changing the training algorithm. That's the one that figures out how it learns from all that data. We tried changing the number of neural network layers. That's just how many neurons you have. But nothing really helped too much. Secondly, we tried using the NARCs, which is a nonlinear autoregressive exogenous network, which is a bit better for dynamic prediction and complex systems. Here also, initially, we didn't get the best result, around 9.6%, but then we tried to change different things on it. We tried to change the number of feeder neural networks, errors, and so on. And then we noticed something interesting, because if you look here, the blue one, that's the actual measurement, and the orange one, that's the one we were getting from our model. So if you look at that, what can you see? I'm curious. Yes? Any other opinions? Exactly. So it's actually delayed by a few samples, if you look at it. It fits quite well, but it's a bit delayed. So what we did is we just changed the input and feedback delay And by doing so, actually, the model fitted quite well. So what are you going to do with this model? Now you have the model. Now you can model the temperature of the main gear bearing. What are you going to do with it? So this is where we start talking about predictive maintenance. Maintenance is when you take care of a component. So in wind turbines, normally you have some components which you change out 5, 10, 15 years. And then you can do this servicing in different ways. One of them is called proactive. It means that you change the component before it breaks. You know that it's going to work for 5 years, but you want to be sure, and you change it every 4 years. And why this is important is when you have some wind turbines offshore, it's very expensive to go out and do the servicing. It's also very expensive if the turbine is not running and making electricity. So you want to have it running all the time. The other one is reactive. That's basically when shit happens and you do something about it. So the component breaks and then you replace it. And the last one is predictive, when you use some kind of smart algorithm or machine learning to try to figure out when it's going to fail. And this is where the model comes in. So what we did is we tried to calculate what's the health of the component. And then the way you do this is that once you have your model, which you trained and it's working, you start comparing that with the actual measurement. And why this works is that imagine that you have the wind turbine, and then imagine that the bearing starts wearing down, starts making weird sounds, it starts heating up, it doesn't work correctly anymore. But the components around it still work. So the temperature getting inside the box is still the same, the temperature outside, and also how fast the shaft is rotating or how much power the turbine is producing. So all the other factors stay the same, but this one starts changing. And then when you start comparing the two, so in this case, the blue one is the actual measurement, and then the red one is the one we get from our model. And then the yellow one here is the error we calculate. So when the difference between the two starts increasing, then you can actually tell that something must have changed in the component. So in this case, for example, already here, you can set a warning and you can see, okay, I have a feeling that this is going to break in a few weeks. And then in a few weeks it breaks. And I won't go into the details, but this system already exists and it's working in the wind industry.
How big was your original data set? I saw 10 windmills there.
Yes, yes. Let me just check. I don't know if my slides are there. Okay. For some reason I'm missing some slides. It always happens. But basically we had data from 80 turbines across 5 years. And the measurements were every 10 minutes. So I don't remember, I think it was 30 or 40 gigabytes of data. And then we decided to select, so do you guys have like a marker or something?
The red one.
I'm just going to try to draw it. Okay, so you had the wind farm, and then the turbines were arranged like this. So okay, something like this. And then the way we decided to do it was to take the turbines from the outside and from the inside and use this as our training data. And then we picked some other turbines as a validation data. So something I didn't mention with machine learning is that you need to train your model with one data, and then you need to validate it with another data. That's how you prove that it actually works. So in this case, we just chose some turbines that are on the outside and some on the inside, so that we try to guesstimate the ideal choice. But this was like really a heuristic approach where you just like say, okay, I'm just going to do this. And we don't know if it's the right one. So there's a lot of things we didn't try. We didn't try using other kinds of variables and so on. But what I wanted to share from this is that it was an interesting journey to go from not knowing anything about machine learning into actually making something that kind of works. And it also kind of makes you be a bit more humble, because machine learning is no longer something that you just throw around like that, but you actually consider that takes some effort to do it, and also you can't just use it to fix everything.
Now, how long did it take you to do the training?
In time, not that much actually. I think depending on the number of neural layers, in the end it only took a few minutes. But we didn't train with all the turbines. We just chose a few of them because the main thing that the company wanted out of this was to get something that's generic, something that you can apply to all the turbines. Because one of the issues is that even though it's exactly the same turbine, they are very different because this turbine gets more wind than this one. This turbine gets more wind than this one, and they are affected differently. So over time, you can't just have a statistical model, a mathematical model to estimate the lifetime, because turbines are different. Yeah. I just have two pictures I found really funny about machine learning and how you can fix it or how you can use it for everything. Yeah. That was it from my side, so thanks for the attention, and if you have any other questions, just hit me.
How are you using the data that actually collected in Novus business? I mean, are you just using it for improving the garbage collection with the company, I mean, the operator, or are you actually using it, for example, to prepare in advance, like the recycling centers or something, or just?
Yeah. So right now we're at the stage where right now we're just collecting the data, but we're also working on having a navigation engine. We call it like that, but basically it just takes all these data points and then it will try to find the best route to collect it with. So let's say that you can see that this bin is full, this bin is full, this bin is gonna be full soon, this is soon, and then you can make the route so that you collect only those ones.
But it's still in the data collection stage.
Right now, yes, and right now we're also in close communication with the municipalities, and we're trying to integrate it in their IT systems because it's very interesting to see how two cities can have very different ways of doing things. Some are in the Stone Age, some are in the future. So it's and this was in Denmark. And right now we're just trying to see if we can integrate it with their system so that we can try to improve the way they are collecting the waste right now, instead of bringing this whole new fancy system that they might not know how to use yet.
About getting sensors, because you might find a lot, but they don't really comply with what you're looking for. For example, I don't know, the refresh rate or something that actually you need. More every 5 seconds, 10 seconds, depending on the application. And then you don't find actually one in the market. So you really go for the one that you get data every 2 minutes, just to make the first prototype, the concept, and the level 3 IP. You just decided to go like let's go.
Yeah.
You found something that works.
Yeah.
But if you don't, let's say.
Yeah, if you don't, then I would probably go for the one that's closest to what works, because if you have to make the sensor on your own, that's going to cost a lot of money. So even if you might not have the 100% correct data, if you can have some data that shows something, it would still be better. But of course, if you want to scale up and if you want to turn it into a product, then you need to have the accurate measurements. But in our case, like just to give you guys an example, we are measuring every hour right now, and we can have a battery life of like 2 or 3 years like this. And we're working on improving that a bit more as well. So LoRaWAN is very good for having low power stuff. Yeah, no, please.
For each measurement you're sending through, for example, for each GPS point, but you're not measuring GPS.
No, it's only measuring the filling level.
But for the other one, for the tracking of the points, do you know actually more or less how much is the power consumption of a GPS, each GPS point,
fixing,
say, over LoRaWAN?
Well, I would say that the big consumption is not the LoRaWAN itself, it's getting the GPS fix. Yes. Yeah, exactly. I don't know exactly, but I know that for the tracking one, we actually had to lower it to once a day. Then we had to turn it off. because it got in a container. But here you have actually some very low power GPS modules that you can use. However, right now LoRaWAN doesn't support it, but I think in the future it will, the triangulation. So if you have 3 gateways, then you can kind of figure out, where it is depending on the signal strength. And Sigfox is offering it. Like Sigfox is another connectivity option, kind of like LoRaWAN, very similar, but they are commercial. So you have to pay them per messages. And they have the full network set up, but you have to pay for it.
No more questions?
All right. Well, you have my LinkedIn there, you have my email address. So if you want to connect, if you want to share some stuff, feel free to do it. And I will also leave some business cards in case you want to.